Welcome back, Bafundi. Once you have gathered information, you are now in the position to state your hypothesis. A hypothesis is a statement which predicts a possible answer to your question. It is important that this hypothesis is testable. Some people have called a hypothesis a testable guess, but it is more than just a guess because you will have based your hypothesis on the research you did. I think it's better to call a hypothesis a testable, educated, possible answer. Why must a hypothesis be testable? Because you're going to design an experiment to test to see if your hypothesis is correct or not. A single experiment can never prove that something is always true, but it could prove that it is not always true. Now, Kumbulani, remember imizekelo wethu earlier. Remember our examples earlier. If you ask the question, why does grass turn yellow under the brick? A possible hypothesis could be the grass turns yellow because it does not receive any sunshine. This is a testable statement that is possible to answer to the research question. If you ask the question, does temperature affect how sugar dissolves? A possible hypothesis could be more sugar dissolves in hot water than in cold water. Notice that a hypothesis is never posed as a question. You must write the hypothesis as a statement. A question asks why something is the way that it is. A hypothesis is a possible answer to the question. What have we covered so far? You have seen that the scientific method begins with observations which lead to the posing of a question. After the question has been asked, the scientist will then do some research in order to state a hypothesis. Now that you have stated the hypothesis, you have to design an experiment that will test the hypothesis. This means that you will be planning a procedure which is a fair test of the hypothesis. Your first step in this experimental design is to identify all the variables. Variables are different factors that could change in an experiment. If an experiment is to be a fair test, then it is important that all the variables are kept constant and only one variable is allowed to change. The variables that you do not allow to change are called constants. In most cases, investigations should have an experimental group and a control group. Your control group is given the normal conditions or the variable you are allowing to change is absent. The experimental group is given the test conditions with the changing variable. The idea is to compare the experimental situation to the control situation. Now, Kumbulani, remember your hypothesis, more sugar dissolves in hot water than in cold water. Well, you could design an investigation in the following way. You measure out identical volumes of water into identical sized beakers. You measure out an identical amount of sugar and place it in another beaker next to each beaker of water. You are keeping the variables constant. You will then heat each beaker to a different temperature. Heat is the variable that you are changing. One of the beakers that is not heated at all will be your control. You decide that you will stir in as much sugar as possible into each beaker. You will stop adding sugar when you see that no more sugar is able to dissolve. You'll then be able to determine which beaker used the most sugar. Was it the beaker with the hottest water? Was it the beaker with the cold water? Did heat have no effect at all on the amount of sugar that was dissolved? When you design the experiment, it is important that you write the method or procedure up in step-by-step point form notes that are easy for someone else to follow if they were copying your work. Now remember that scientific knowledge is validated when an experiment is repeatable and produces the same results each time it is done. A test of whether you have written up your methods correctly is can someone else follow your method precisely and get the same results as you did. It is also important to list all the equipment and materials that you used. Once you have designed the experiment, you are ready to move on to the next step in your scientific method, conducting the experiment. It is important that you follow the steps of the method you have designed. If you need to change anything, you need to make careful note of precisely what you changed, when you changed it, and why you changed it. You also need to make sure that you carefully observe what happens and that you keep detailed records of the results. Make accurate observations and measurements. Also remember that an experiment should be repeated at least twice for valid results. Another way of ensuring valid results is to use a large sample size. In our example of testing whether heat has an effect on the way sugar dissolves, you would repeat the procedure a few times to verify what you observed the first time was correct. You would keep detailed records of the temperatures of the beakers and how much sugar dissolved in each beaker. Sabonana kakhona emva kwe break.